All right, guys, so this is our Chapter 4 project for statistics. So what we have here um, is we're going to be effectively making a simple casino slash gambling game. Um, Emphasis is on the word simple here. Also, I want a little disclaimer here. There is no actual gambling. We're just going to be working on this purely as a way to practice our probabilities and things like that. It's just a more fun way of doing it. So, using some combination of playing cards, dice, and polyhedral dice, we're going to try and create a game. Um, Now, this is a game which only has two particular states. Either you win it or you lose it, right? We don't want stuff where, oh, you can win more if you do this or win less if you do this. Those are fun, but those are way more complex than we want right now. Okay, in the future, you might be able to do those if you choose, but right now we're going to say, hey, there's either a win state or a loss state. Okay, so the key here is in you trying to get your probabilities to be in a very specific window that I have defined for us. Now that window is between 45 and 49%. So this is kind of in line with a lot of actual casino games, right? They want you to win just under half of the time because then you will actually want to keep on playing because you feel like, hey, I am winning a decent A-like amount, but still overall in the long run, you're going to be losing more than you're going to be winning. So you need to have your overall probability of winning be between 45 and 49%, right? So, well, how can we do that, right? So if you think of a very simple game, like if I roll a six-sided die, right? If I roll a 1, a 2, or a 3, then I win. A 4, a 5, or a 6, then I lose. Well, that's 50-50. That's also an extremely boring game, right? So then, well, how can I try and go past that? Well, this is where we need multiple phases. So you're going to need at least two phases in your actual game, right? So I call them phases. Probability-wise, in the definition, they're events, right? So I would first roll a die, and then maybe I draw a card, right? So if I roll a 1 through 3, then I need to draw a face card. Or if I roll a 5 through 6, then I need to draw a red non-face card, right? So what are the probabilities of each of those things? And then the different outcomes can give you either a win state or a loss state. Now, when you calculate up your total probability of a win, it needs to be between 0.45 and 0.49. So you can keep adding more and more phases to kind of help you get exactly there, but try and not go past 3 or maybe 4 phases. And that's only if they're relatively simple, because again, we want to keep this game relatively simple so that when we play it, it's playable, right? Um, so tools that I'm going to have at my disposal for you, if you would like, I have decks of cards, which you are more than welcome to use those. I have standard six-sided dice. I then have a number of polyhedral dice. These are your standard polyhedral sizes. I have four-sided dice. I have six-sided dice. I have eight-sided dice. I have 10-sided dice. I have 12-sided dice, and I have 20-sided dice. Right? I do also have some that are 30-sided, but not a whole lot of those. So try and stick with those. So how could I use those or some combination to get my probability in that particular range? Now, this is going to take a lot of guess and check and trial and error, and that's okay. That's part of the point, right? So how to get there exactly I have here in the actual conditions for it, right? You're going to want to make a probability tree out of it. So those little branching trees of, well, if I draw an ace or draw a non-ace, right, then I have those different branches. And then your final branches should say which ones of those win, which ones of those lose. And then if you find out the probability of every winning branch and add all of those up, your total needs to be between 0.45 and 0.49. If it's too high, well, then you need to reduce the chance of someone winning. If it's too low, you need to increase the chance of someone winning. This is going to take trial and error. So if it doesn't work on the first thing you try, that's okay. Revise, try A again. This is that engineering process of trial and error until you get the result you're actually trying to get here. So again, the requirements of the game specifically, the probability between 0.45 and 0.49 has a minimum of 1 and or condition. That means that this happens and then this happens, or this happens or this happens. So you need at least 2 phases there in order for that to happen. You can be played with some combination of cards, dice, and polyhedral dice. I'm limiting you to just those things because I don't want to go beyond stuff which you would normally find in a casino. And then it only has 2 outcomes, like I mentioned earlier, either a win state or a loss state. This means you can't have, oh, you win more, or there's a jackpot, or things like that. Again, that can be fun, but we're not there yet. That's way too complex for where we are currently at as far as our probability knowledge. So once we have that, what you need in your final product, which you will be turning in, is first an explanation of how the game is played. Keep it simple. Don't try and write some elaborate, really wordy kind of story about, hey, here's how I was inspired to create this game. No, just say, hey, you roll a die, a 1 and a 2 is this, a 3 through a 6 is this, something like that, and then go through each of those phases and, hey, here's how you win, right? Then draw me a probability tree of all of the options in your particular game with the probabilities labeled on each of those branches as you go through, and then your final probability for each of those outcomes, right? And then explain to me how you got those probabilities, right? Just give me a tree with some fractions on it which work out is nice, but I want to know, hey, how did you get that the probability of this was 4/9, right? How did you get that this probability was 1/3? This is a really short explanation there. It doesn't need to be some grandiose essay. Just explain to me in plain English, hey, here's how I got this, right? So with that, this is going to be due Tuesday the 17th. That is the Tuesday before Thanksgiving break. And if you guys have questions, please feel free to ask me, and I will talk to you guys next time.